I'm going to go over some problems from the Math 3 Unit 2 Worksheet 5. We're going to start with number 3. The instructions here are to accurately graph f of x and g of x on the same set of axes. So f is a quadratic equation, g is a constant equation, and we'll start with f. It is going to be in the shape of a parabola, and it's been translated left 3 units, up 2 units from 0, 0. And if we plug in, let's say, x equals -2, we get f of -2 is 2 times -2 plus 3 squared plus 2. Follow the order of operations. Parentheses, exponents, multiplication, addition. So we get f of -2 is 4. So that gives us the point -2, 4. And that's the right side, and we can reflect that on the other side of our vertex. And there is our function f of x. G of x is equal to 0, and that is the x-axis, y equals 0. And part A is asking us, where does f of x equal g of x? In other words, where do they touch or cross or intersect? And they don't anywhere. And so f of x is equal to g of x nowhere. So there's no solution. Let's see what happens when we solve this algebraically. So f of x, we said f of x equal to g of x. We get 2 times the quantity x plus 3 squared plus 2 is equal to 0. I'm going to subtract 2 from both sides. Divide by 2. And we should notice something wrong already. Whenever you square a number, as long as you're working with real numbers, you should get a positive answer. And here we're getting -1, so that should already be an indicator that we're not going to have a solution. If I keep working through this, I take the square root of both sides. And another indicator here is if you take in the square root of a -1, you're not going to have a real solution. So I'm going to stop here. And real is the key word here. So there's no real solution. There is an imaginary solution, but no real solution. Let's skip now to 6. Solve the following quadratic equation. It doesn't specify how. There are different ways to do this. But if you have an expanded trinomial like this one, try factoring first. If factoring doesn't work, use the quadratic formula. So we're going to try factoring it. Here we have a trinomial where the leading coefficient is 3, not 1. And so I'm going to multiply 3 times -4, and I'm looking for two numbers that multiply to 3 times -4, which is -12, and add to that middle term -11. So you start with factors of 12. 12 is 12 times 1. And if you subtract 12 and 1, you get 11. And then start playing around with what should be positive, what should be negative. And if you work with -12 and +1, those The product of those two is negative 12 and the sum is negative 11. And so we found them. So we split our three terms into four terms. Leave the first the same. Split up the middle to negative 12x and positive 1x. And leave the last term, 4. And then factor by grouping. Group the first two, factor out 3x from the first two terms, and you're left with x minus 4. And factor out a plus 1 from the last two terms, and you have an x minus 4. Both terms have an x minus 4. Factor out the x minus 4, and we're left with 3x plus 1. Then we can set our factors equal to 0. And first equation gives us x is 4. Second one we set equal to 0. And we end up with 3x equals negative 1, or x equals negative 1/3. Number 12. It's factored but not equal to 0, so we need to multiply. So x times x times 3 gives us x squared minus 3x equals 7. Make it equal to 0 by subtracting 7 from both sides of the equation. And then go for factoring. Here we have a trinomial where the leading coefficient's 1, so we are looking for two numbers that multiply to negative 7 and add to negative 3. 7, the factors of 7 are 1 and 7, and that's it. And we're not going to get a negative 3 out of that, so this does not factor. And so we're going to use the quadratic formula. Quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2 times a. And in this problem, a is the number in front of x squared, which is 1. B is the number in front of x, which is negative 3. And c is the constant, or the number without x, or a variable, which is negative 7. Plugging those numbers in, we get negative from the formula, negative 3 for b, plus or minus square root, negative 3 squared minus 4 times 1 times negative 7 all over 2 times 1. Continuing on from there, negative 3 gives us positive 3. Square root, negative 3 squared is 9. 4 times 1 times 7 is 28, and we have two negatives, so it's actually positive 28 all over 2. Keep going. 3 plus or minus 28 plus 9 is 37 over 2. And just check, see if we can reduce or simplify that square root. We can't, and so that is our answer. Number 15. 15, we have, we're going to solve for x plus 7 squared first by subtracting 20. And we get negative 54. Dividing by 3. And we get negative 18. Taking the square root of both sides. And the square root of the left side is the absolute value of x plus 7. And that's equal to square root of negative 18. So x plus 7 could be positive or it could be negative square root of negative 18. when you have a square root of a negative number, you're working with an imaginary answer. And just checking the instructions here, it doesn't say we can't, so we're going to work with it. I'm going to get x by itself, so subtract 7 from both sides. We get negative 7 plus or minus square root of 18. 18 is 9 times 2. So, and that negative sign is really the square root of negative 1, which is the imaginary number I. So we got I square root 9 times square root 2. And we know the square root of 9 is 3. So this is negative 7 plus or minus 3i square root of 2. And we'll stop there.